Now, we already talked about the properties of congruence in the last section. It just kind of repeats them here, reminds you that reflexive, symmetric, and transitive properties all work for segments, so we can use that. Hint, when they give you something like that, that's probably something you're going to use in one of the problems. So it's always they're not going to pull something out of left field all the time. They're usually at some point going to require that you use something that you learned in this section. And in the beginning like this, they're going to remind you of these things. And they give a number for the theorem. You don't need to know the number for the theorem, particularly if it has a name. You're just going to want to use the name for whatever it is you're trying to use to justify your proof. Example 2. Prove using segment congruence. The route for a charity fitness run is shown. Checkpoints X and Z are the midpoints between the starting line. Ooh, that's a good word right there. Midpoints. We should make sure we know what midpoints mean. Checkpoint Y and Y and the finish line. Oh, okay. I see what it's saying. It's saying X is the midpoint of this section to the left, and Z is the midpoint of the segment to the right. That's what the word respectively means in there. It's referring back to them in the proper order. If checkpoint Y is the same distance from checkpoints X and Z, so now it's not only saying that we have midpoints here, but these two segments here are going to be the same distance, which means they're congruent. Prove that the route from checkpoint Z to the finish line is congruent to the route from starting line to checkpoint X. Okay, a lot of stuff going on in this problem. And the first part is always decoding what they're asking you to do. So we need to figure out what do they actually want us to prove. They want us to prove that the segment from Z to F, Z to the finish line, is congruent to the starting line, S, to checkpoint X. So what they're trying to prove, what they want you to do here is to prove Sx is congruent to ZF. Now, what else do we know about the problem here? They tell us that X and Z are midpoints of the segments. So these two segments are congruent. And they tell us that those two segments are congruent. So let's write that down in our given. Sx is congruent to xy, and yz is congruent to zf. All right, is there anything else that's given to us? Yes. If checkpoint Y is the same distance from checkpoints X and Z, so they're saying Y down here is the same distance from X and Z. So it's saying, I'll highlight in yellow here, that the two yellow segments are congruent to each other. So we say XY is congruent to YZ. All right. Now, we've got all these givens. We know what we're going to try to prove. We're probably going to be using these properties of segment congruence here. Let's set it all up. So, use nice straight lines again. Sometimes when I do these, I get too fast and too sloppy with it, so my two columns don't come out to be very nice. Graph paper is a good way to organize this. You can draw straight on those lines, or if you're using lined paper, draw the starting line at the top, draw a vertical line down, but give yourself good space on either side of it. This is one of the things, it might take lots of piece of paper, particularly in the beginning when you're first getting started in it, but that's okay. So here on our left we have our statements. And I've been using reasons this whole time, but you can also use the word justification. The justification is the rule of logic that we're using for our deductive reasoning. Let's start listing off what we know. We got a bunch of segment congruences. And since I spent the time making this list of knowing what's given to me, it's really easy. I just copy that same stuff down. ZF. And the last one is XY is congruent to YZ. And all of that is given to us. And at some point we want SX and ZF to be equal to each other. So a good way to do this, and it's really easy for me because I can highlight it, is to kind of highlight, do either of those things that we're looking for exist in my given statements? Yeah, I have ZF and I have SX. And in between them, in both of those things, they are both related to XY, which is down below, and YZ, which is also down below. So you can see I've got all these colors together, right? So I want SX on the left, so I'm going to start with what I know about SX. SX is congruent to, it's congruent to YZ, or sorry, XY. You can see that here in the blue. What else do we know that that's congruent to? Well, it's congruent to YZ through the transitive property. All right. And we also know that YZ is already congruent to ZF. So I can use SX congruent to ZF. Again, we're using the transitive property. And oh, look at that. Well, we are already at what we want for our conclusion. And there's the end of our proof.